Welcome to our video on the exciting advances in AI being made by Microsoft and NVIDIA. In this video, we will explore two powerful AI tools developed by these companies, Microsoft's Rauden and NVIDIA's Rana. We will delve into the technical details of how these tools work and see examples of their impressive capabilities. Stay tuned for a closer look at the cutting-edge AI technology being developed by NVIDIA and Microsoft. Text, photos, and even videos are transformed into 3D avatars using cutting-edge artificial intelligence. Anyone can now create a super realistic 3D avatar from an image or a simple text description using Microsoft's Rauden. Rauden is a 3D generative model that uses diffusion models to generate 3D digital avatars represented as neural radiance fields automatically. The memory and processing costs in 3 dimensions are prohibitive for producing the rich details required for high-quality avatars, which is a significant challenge in generating such avatars. To address this issue, researchers from Hong Kong University of Science and Technology and Microsoft presented the Rollout Diffusion Network, abbreviated as Rauden, which represents a neural radiance field as multiple 2D feature maps and rolls these maps out into a single 2D feature plane where 3D-aware diffusion is performed. The Rauden AI model improves computational efficiency while maintaining the integrity of diffusion in 3 dimensions. Latent conditioning is also used to orchestrate feature generation for global coherence, which results in high-quality avatars that can be semantically edited with text. Finally, hierarchical synthesis is used to improve details even further. The model's 3D avatars compare favorably to those produced by existing generative techniques. The model can generate highly detailed avatars with realistic hairstyles and facial hair, and it can not only generate 3D avatars from images or text, but it can also edit those avatars with text prompts. DALL-E 2 from OpenAI and Stable Diffusion from Stability AI, two well-known generative models for creating realistic and attractive images from complex text inputs, are two well-known generative models for creating realistic and attractive images from complex text inputs. Their architectures are also based on diffusion models, which have demonstrated exceptional generative power for images and videos. Rapid advances in diffusion and generative modeling have resulted in a revolution in the creation of 2D content. The idea is simple. If you can describe it, you can visualize it by allowing the model to create it. Generative models are capable of incredible things, and while 2D content has been a challenge for diffusion models up until now, 3D content has posed more difficulty. As digital avatars become more prevalent in movies, games, the metaverse, and the 3D industry, the ability for anyone to create a digital avatar can be extremely useful. This was the impetus for the creation of the Rauden Rollout Diffusion Network for avatar creation. The model works by taking an image, random noise, or a text description of the desired avatar as input and then generating a latent vector to be used in the diffusion process, which includes several noise and denoise steps. To produce a clearer image, random noise is first added to the starting state or image, followed by denoising. The 3D nature of the desired content makes this case unique. The diffusion process then continues as usual, but instead of aiming for a 2D image, it generates the coarse geometry of the avatar, which is then followed by a diffusion upsampler for detail synthesis. The artificial intelligence researchers used a triplane representation of a neural radiance field to increase efficiency, which has a much smaller memory footprint than voxel grids without sacrificing expressiveness or quality. But what if you could use a video for input to create an ultra-realistic avatar of not only a face, but an entire body too? To accomplish this, NVIDIA artificial intelligence researchers recently proposed Rana, a relatable and articulated neural avatar, abbreviated as Rana, for the photorealistic synthesis of humans from any viewpoint, body pose, or lighting. To create the avatar, all that is required is a short video clip of the person, and no knowledge of the lighting environment is required. The artificial intelligence researchers present a novel framework for modeling humans while separating their geometry, texture, and lighting environment from monocular RGB videos. To simplify this otherwise difficult task, they first estimate the coarse geometry and texture of the avatar using SMPL+D model fitting and then learn an articulated neural representation for photorealistic image generation. How it works is that Rana first generates the normal and albedo maps of the person in any given target body pose and then uses spherical harmonics lighting to generate the shaded image in the target lighting environment. Then, video researchers also propose pre-training Rana using synthetic images and show that it leads to better separation between geometry and texture while also improving robustness to novel body poses. Separating the texture, geometry, and illumination information is necessary for relighting in different contexts, but is a challenging task when working with RGB footage. To overcome this, the researchers used a statistical human-shaped model to obtain coarse geometry and texture data from the training frames. NVIDIA then used a convolutional neural network trained on artificial data to remove the shading information from the coarse texture. To capture person-specific characteristics for a new subject, a new set of neural features are learned, and according to the research, it's possible to create an avatar for a new subject after just 15,000 training iterations so far. Rana is the first technique that allows neural avatars to be both relatable and articulated. Articulated neural avatars that are similar to humans have various applications: telepresence, animation, and the production of visual content. These avatars need to be easy to create and animate in different poses and viewpoints, able to render photorealistic images, and simple to adjust lighting in different scenarios in order to be widely used. One common technique for creating these avatars is through the use of monocular films, which allows for movement and realistic image quality, but the synthesized images are limited by the lighting conditions in the training video. Other methods for relighting human avatars have been proposed, but they do not allow the user to control the body's pose and often require the use of multi-view photos taken in a controlled environment using a light stage for training. Now, with NVIDIA's relatable articulated neural avatar technique called Rana, the above-mentioned problems are solved by creating photorealistic human animations in any body posture, perspective, and lighting scenario. This technique simulates the complex articulations and physical characteristics of the human body in order to achieve this level of realism. Another recent breakthrough from Stanford, called Point Avatar, is an artificial intelligence that can create 3D head avatars from videos. The ability to create realistic, animated, and relatable head avatars from casual video sequences would have many applications in communication and entertainment. Current methods either use explicit 3D morphable meshes, known as 3DMM, or neural implicit representations. The former are limited by fixed topology, while the latter are difficult to deform and inefficient to render. Additionally, existing approaches combine lighting and color estimation, limiting their ability to re-render the avatar in different environments. In contrast, the artificial intelligence researchers from ETH Zurich, Max Planck Institute for Intelligent Systems, and Stanford University have proposed Point Avatar, a deformable point-based representation that separates the source color into intrinsic albedo and normal-dependent shading. Point Avatar combines high-quality geometry and appearance with topological flexibility, ease of deformation, and rendering efficiency to bridge the gap between mesh and implicit representations. This method is able to generate realistic 3D avatars using monocular videos from various sources, including handheld smartphones, laptop, webcams, and internet videos, achieving state-of-the-art quality in challenging cases where previous methods fail, while being significantly more efficient in terms of training when compared with other methods. What do you guys think? Let me know in the comments below. And if you haven't already, make sure you guys hit like on this video.